the first portion that we're going to go over for the first lesson is basically what happens when we're dealing with multiplication and we're dealing with exponents in different positions. So let's say I start off with, well, there's three different types of things we're going to be dealing with. One, we have the same basis, and so A and A are the same, but the exponents are here and here. So if we have the same base, we can literally add exponents. So that's like saying if I have y to the fourth times y to the fifth, another way of writing that would be y to the fourth times y to the fifth. This is the same as saying y to the fourth plus 5. Those exponents are added together, and you produce 9y's. This is my final answer. We're not going to go to the right just yet. We're going to do number 4. So I have the same base all the way across. If you look, here's the base. It's x, 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 x. And similarly to how we deal with coefficients when there's no number in front, when there's no exponent there, we can assume that the exponent of a base is the 1 power. So what does this look like? We could see it like this. We could also see it like x, x to the 6th, x squared. Regardless, what we should end up doing is saying, put a 1 up there, x to the 1 plus we're adding those exponents, and we end up with x to the 9th power. Okay? Now, what happens when we bring numbers into the mix? Well, when we bring numbers in, like in number 7, it says 3y to the 7th times 4y squared. You need to rearrange. So rearrange like terms. And technically, we're just going to be multiplying those numbers and putting those y's together. So if I want to see it in action, it's going to be like saying 3 times 4, and then y to the 7th, y squared. So 3 times 4 is 12. Y to the 7th plus 2, we still do the step we need to do, equals 12 y to the 9th. Let's look at the next one. We're in the same type of situation. We rearrange like terms. Numbers go together, coefficients go together, and variables that are the same basis go together. So here I have 2 times 6, and then x to the 5th, x cubed. When I do that, I can kind of see a little bit better of what I need to do. Well, 2 times 6 is 12. X to the 5th plus 3 equals 12. X to the 8th. All right. So that's adding exponents. So if there's numbers involved, we multiply those numbers first. Okay? So the only concern we have to do is worry about if there are numbers. So if there exist numbers, you need to multiply those numbers first. So coefficients only. Now, what about when I'm in a situation where there's a base inside? There's a base inside to a power, and a power or an exponent outside. So what you're going to do is distribute to that power inside. So distribute, which means multiply exponents. So Always draw your arrow from one exponent to the other, especially if there's parentheses. So only inside 5 distributes to 4. That means this equals y to the 4 times 5. Unlike before, where you were adding exponents, this is y to the 4 times 5. This equals y to the 20th power. Final answer. Next problem. Now, remember, we got to be careful here. Only on the inside is that 2, inside of the parentheses, is that 2 distributing. So 2 distributes to the m on the inside. There's no number there. We can assume it's 1. But it doesn't do anything to 2. So 2m squared. That's my final answer. Let's look at the next one. Now we got to be careful here. This 3 is distributing to the 5 and to the x. So I have 5 cubed x cubed. Now, x to the 6th, there's nothing out here. Those parentheses just fall away. Now I'm in a situation where I have to first evaluate the number. Well, 5 to the power of 3 is 125. But the x's, they're side by side, so I'm in this first situation where I'm adding the exponents. This equals 125 x to the 9th power. The last one, it says -2 is cubed. I'm going to distribute it to this 3, so that 1 to that 3, that's -2, parentheses, 3 times 1, this is -2 to the 3rd power. This equals -2 times -2 times -2, or just -8. Okay? Going back up, I have, what if there's 2 bases inside of raised to a power? So we distribute the term to each base that's inside. So for yx, that quantity raised to the power of 2, you distribute the 2 inside, and it becomes y squared x squared. Okay? So, number 6, I'm distributing this 4 to the x, that becomes x to the 4. And then I distribute the 4. You got to be careful. When we're dealing with the exponent inside, it goes directly to that 3, and you multiply. Y 3 times 4, this equals x to the 4th, y to the 12th. Okay? So, look at number 9. The 4 distributes to the 2. I have 2 to the 4th. Then 4 distributes to x. I have x to the 4th. Then the 4 distributes to the 3. I have y to the 3rd times 4. This equals 2 to the 4th is 16. X to the 4th is just x to the 4th. Y to the 3 times 4 is y to the 12th. Final answer. Next, distributing the 3, I have -2 with a 3 to the 3rd power. Then x to the cube power. Then y to the cube, so y cubed to the 3rd. We could have just distributed, and we get -8 x cubed y to the 3 times 3 equals -8 x cubed y to the 9th. Okay? Next page. Now, this is independent practice. Make sure when you're doing these problems, you describe what to do with the exponents before you get started. So number 1, it says distribute, multiply, distribute, or you could write distribute, or you could write multiply 2 and 3. So x to the 2 times 3 equals x to the 6th. For number 2, describing what happens, I'm distributing 4 to 3, or you can write distribute. You could also write multiply 3 times 4, 3 and 4. That's 2 to the 3 times 4, which equals 2 to the 12. You simplify by using your graphing calculator. When I go to the graphing calculator, I put in 2 up arrow 12, enter, and I have 4,096 as my final answer. The next one, you distribute and multiply those exponents 9 and 10, and you simplify. So that's independent practice for this lesson. Next, we have exponents and properties for three-dimensional shapes. So things you need to know. The perimeter of a square is 4 times the length of a side. So S is the length of a side. What you're doing here is writing formulas. So it says find the volume of 2 cubic crates if S equals 3. So two of these crates would need 2 volumes. Now if volume equals this, right? 2 times S cubed. This equals 2 times 3 cubed, or 2 times 27. This equals 54. Now the units here are cubed, so 54 units cubed. Now it says find the volume of 4 cubic crates. That's like saying 4V equals 4 times S cubed. S here equals, the side length here is 2. So 4 times 2 cubed. This equals 4 times 8. It's 32 units cubed. Next, the area of squares. So 5 squares, area equals S squared. So five areas would be 5S squared, or 5 times 4 squared. This is 80 units, and the units are squared. Okay, just find the area of 2 squares, so 2 areas, okay, equals 2S squared. This equals 2 times 5 squared, or 50 units squared. After that, you have classwork to do, and also you have homework tonight. So independent practice, you're going to need to complete the classwork as well. They are both in-class grades. This took about 13 minutes to do, so now you have approximately 45 minutes to complete the other task before you leave today. Have a great day.